In this session, we have to understand about the concept of Docker Swarm cluster, how we can set up this cluster, what are the benefits, what is the architecture, and how to manage this whole cluster for the different highly available applications. So, right now, what I am using Ubuntu based uh, Linux. Uh, Ubuntu Server Edition. I install these three nodes. They all are on the same subnet interconnected, and I install the Docker on all nodes. So installation of the Docker, is not a difficult job. We already done this in the previous videos. So we have to understand here how to make all these nodes in the form of cluster to make the highly available environment. So we will run a command docker swarm init. Docker swarm init command will initialize the control plane on this node where I ran this command, and it will declare this node as a manager. You see, current node, an ID is given, is now a manager. We will understand what is manager, and uh, it gave us this token on this IP, on this port number, to connect the other nodes with this cluster. So we just have to run this command on another node to connect as a worker node. If I run the command docker node ls, now this docker node ls is a command based on Docker Swarm. In a simple Docker node, you cannot run this one, and you can see it's acting as a leader. But here it's said that it's a manager. So in fact, leader is also a manager. Manager is responsible to run all the administrative commands related to Docker Swarm cluster, just like I ran Docker node ls. Okay, uh, and among the multiple managers, one of the manager will become leader. So there will be election between multiple managers and one become leader, and leader will perform some special task like the deployment of services or relocation of the containers to different nodes. We will see that. But right now we have a cluster with a one node, and if I use this token on my other node and it's quickly connected with my Docker Swarm cluster, and if I run Docker node ls, you can see its manager status is nothing. It's mean it's working as a worker. Now, if I want to regenerate this token, how could I do this? So Docker Swarm, we can run join token. Either I can write worker or I can write manager. So these are the two roles we can assign to any node. So this is a token if I want to make any node uh, as a worker. So for example, I am using this manager node token on this third node, and it's joined to Swarm cluster as a manager. Now I will run Docker node ls. You can see its manager status is reachable. It's mean these two nodes are manager, and the leader can reach to this manager node. Now this is as a worker node, and these two are manager nodes. Manager node doesn't mean they will not have any workload related to application. They will also work as a worker node, they will also work as a manager node, and one of the manager node will also work as a leader. Okay. Now, if I want to, for example, if I go on this node 2 and I run docker node ls, so you can see this node is not a manager. That's why you cannot do the cluster administrative related task, cluster modification related task from any worker node. Only the node that are part of manager, of the cluster manager, can perform the administrative related task. Docker node ls, you can see these this node can also perform the administrative task. So these two nodes can perform the administrative task only. Now I want to elevate this node to also as a manager node. I can have hundreds of um, a lot of tens of worker nodes and manager node, but at least you should have three manager nodes to make the highly available environment. If we lost any of the node, for example, you are running a cluster with only one manager node, and if that node is down and not recoverable, your cluster is gone. So you must have to make sure at least one manager node is up and running. So now I want to elevate this node to also as a manager node. How I can do? There is a command docker swarm, docker node. Uh, if you do a double tab, you can see there is a promote. Okay, and just I just then I have to provide the node and host name, or you can provide the ID. Anything you can provide. So now you can see it's also promoted as a manager. Docker node ls. It's also reachable, mean it's also a manager. Leader can reach this, and here you can see the if I run the command from this node to, it can also administrate the cluster. So now we have to understand what changes have been made after this, after making this node as a Docker manager. So if I run the netstat in tup command, I have not shown you this command. I should run this command earlier before joining this node to the cluster. So before running Docker in it, you will not be able to see 2377 port, 4789 and 7946 port. What are these ports? So this is the complete documentation I prepared. You can see this in the Git repo as well as in this video description. So here I explain what are these ports used by Docker Swarm management. So these ports are used for communication between manager and worker nodes in the Swarm cluster. 2377 port used for Swarm management and control plane communication. When I ran Docker Swarm init, this port quickly open, and manager node listen on this port for incoming connection from other nodes. Used for the cluster state management, leader election, and raft consensus. Raft is an algorithm that is used to do the election. 7946 is a TCP and UDP port, and it is used to make the intercommunication in between the control plane nodes only. Those are the manager nodes, and they will talk with each other, like we can see here, reachable. So these all nodes are intercommunicating with each other on this port. And enable node to discover and communication with each other, used for node membership and health check. And this 4789 is a UDP port and used for overlay network traffic. So what happened now? These all nodes are interconnected with each other. 7946 port you can see open, 4789 port is open, 4946 7946 is open, and you can see the node 3 and node 2 is connected on this port. they are communicating with each other, and also they are communicating with 2377. Okay, and 7946 is a port that is used for the health check, and 13, and there is one more port that I showed you, 4789. 4789. This port is used to open the VXLAN tunnel in between these three nodes. So whatever node is working as a manager or as a worker will be interconnected with by using this VXLAN. Either your nodes are on the different network, or there are firewalls in between your nodes, or they are residing in different regions, different location. These ports must be open and reachable to make the cluster workable. Okay, so VXLAN is the extended layer 2 network. So if there is a router in between these worker nodes, even though they can talk on layer 2 protocol. So now if I show you IPA, so you can see this bridge is created, and this bridge is making on all the nodes. So this bridge is created, and this bridge is responsible to make a VXLAN tunnel in between all the nodes. So whenever we will deploy the different containers, so the containers can communicate to each other, and different services can communicate to each other across the different nodes. Now we understand this ports concept. So now we understand the init, the join token, manager, worker, later on join command, and if we want to promote, and we promoted one of the node as worker node as a manager, and Docker node ls is working fine. Now if this leader goes down, for example, I'm going to power off this node 1. So what happened, because this was working as a leader, now if run docker node ls, now this node is not reachable, and again the election will happen, and one of the node will work as a leader. Okay, so now if I run docker node ls, you can see this node is not reachable, and this node has been promoted as a leader. Docker node ls, so this whole state is propagated everywhere, and this is declared as initially it was declared as unknown, and now it is declared as down. Okay, so with this way the nodes will the cluster will check the status of the manager node. Now I will power on this node again, and after some time it will again be back as a reachable as a manager node, and this will remain leader until unless it is not going to be demoted, or its services are down, so it will remain leader. So after some time we can see it will be back. Now if we want to demote any of the node, docker node, and you can see we did the promotion. We can also do demotion. We can also demote. For example, I want to demote this node from the manager role. So now docker node ls. Now you can see I am on node 2, And as a manager, I demoted myself. I can do this from any node, but I did on the node 2, and node 2 quickly demoted, and now node 2 cannot run this command. Now I can run this command from here, and you can see it's not reachable and it's working as a simple manager. So with this way, you can demote any node from the manager role. For example, I want to demote this one, so I can do docker node demote either by name or ID. Node 1 I don't want, it is back to work, and docker node ls. Now you can only do the administration from node 3. So these two are now worker. So this is the way you can promote or demote the nodes as a manager. Now we have only one manager, and that is working as a leader. Now we have to understand if we want to remove this node from our cluster. So how you can do, I will connect again with the node. You have to go to that specific node, and that node can decide either that node want to leave or not. So this node will run a command docker swarm leave. Sorry, docker swarm leave. So node left the cluster. Now when I will do node ls, after some specific, there is a heartbeat time in between these nodes, and when now it is declared as down, but it is not removed from the inventory of this cluster. It is declared as down. This can be down due to power failure, but this node willingly remove the cluster. So we know this, and so we can do docker node rm, and we can remove this node either by ID or by host name. Now docker node ls, this node is removed from the cluster. So I want to join it back. So what I will do, uh, in the rest of the whole course, I will use all these three nodes as a manager. So what I am going to do quickly, docker swarm uh, token init, sorry, docker swarm join token uh, as a manager. Just rejoin this node as a manager, and also docker node ls, and also docker node promote node 2 as a manager. Now all are manager. Okay, so that's good. Our cluster is good. Now you have a very clear understanding how to set up and how to join, and what is the concept of manager and worker nodes and leader, and what ports are involved, the intercommunication that are responsible to make the communication. So now we did docker node ls. We can do docker inspect. So I will go back to my this node 1. So docker node ls, docker inspect node, for example, node 1. So you can see all the details about this node, how much capacity it has, what containers are running, CPU, memory. Okay, so this all information is given here. And we can also add pretty that will give some information. Just a minute, let me check. I can use this. No, I cannot use this one. This is only for the service. So I did the inspection of the node. And we already did the promote, demote, and we can do the Docker node update availability drain, and any node we can drain. For example, you are going to do some hardware maintenance of any worker node or manager node. So you will drain that node, mean all the workload will be moved to any other worker node, and it will also be cordoned. In no other workload will be scheduled on this node. So drain a node, stop task, preventing new task. And after maintenance, when the node will be back, so you can run this command docker node update availability active, and it will be back to the work. And we did this. We removed the node when one of the node leave the swarm cluster. So these we will do when we will deploy some service. So now let's go to the service. So what is a service? Service, you can say, uh, is a combination of a load balancer as well as the application running in front. So the container will run, and an IP will be allocated for that service to reachable. We can run a service with multiple container. Then the a specific IP, the load balancer IP, will be responsible to reach all the containers. So, for example, Docker service create, and name of the service I want to give, for example, app1. This is my service, and what image you want to use. For example, I want to use Nginx. So, but this is the Swarm administrative related command. You can only run from manager node. So you can see one service is created. Docker service ls. This one service is created, and one of the out of one replica is by default created because I have not defined any replicas, and this image is used. Now the question is, this container is ran across in the cluster. Where is this container is running? I can use ps and the name of the service. So you can see this container is running on node 2. So if I run here the simple docker command docker ps, there is no container. If I run here docker ps, there is one container. Okay, and here there is nothing. So automatically the load is divided. The container is scheduled on this node 2. Now if I want to scale up the replicas, so I can do docker scale, docker service scale, and what is the name of the service? App1. I want to scale to 4. Okay, so now 3 more containers will run with the same image, and docker service ls 4 out of 4 ready. Docker service ps app1. So here we can see the detail. Node 2, node 1, node 3 has 2 containers, and rest of these two have only one. So docker ps only one, here docker ps 2. So these containers are up, and we can see even docker network ls. So a special network is attached with this service. I will explain you when we will create the dedicated networks. So whenever you are creating a service, so service will, when we are creating multiple services, so services uh, can communicate with each other by name from within the container with each other. But we have not created any special network. So that's why by default, in the Docker, the default network will not provide the DNS service to resolve the name to IP for the applications, for the containers. So, but in the Docker Swarm, we will communicate based on the service name. So what we need to do first of all, I will create Docker network create. For example, I want to create app1 net, and I will use its drivers in the, if we go to network section. So we must have to use drivers overlay. The overlay drivers are only usable by the Docker Swarm. Now we run Docker network ls. You can see this app1net is created with overlay, and its scope is across the all nodes, and it will use the VXLAN tunnel to intercommunicate with each other. So now if we do a Docker uh, service inspect, if we do a Docker service inspect app1. So here in the network section, I believe there is a network section where you can see with which network it is associated. So right now we cannot see here, no problem. So what we will do, we can update the service, any existing service we can attach in the runtime with a different network. So we can use Docker service update add network network add and app1 net, and to which application app1. So now all the containers will be reinitialized with the new network. And you know, when we simply ran the container with Docker command, we cannot switch to the different network on the runtime, but Docker Swarm giving us the leverage just with the one command, all your containers are switched to the new network. Now if I do Docker PS, you can see the Docker service ls 4 out of 4, Docker service PS app1. So all old containers went down and new one are running. So on node 1, now 2 are running. You can see 18 seconds ago, 21 seconds ago, just they ran, they comes up. Docker PS 50 seconds ago. So now this service is using this network we created. Now if I want to create another service, Docker service create, and here if I type hyphen hyphen help, so you can see here how we can expose the port. So to publish the port, I can use hyphen hyphen publish or hyphen p. So I will use create the name, for example, app2 I want to create, and hyphen hyphen network I want to use app1 network, app1 net, and I want to publish the name. I will give something meaningful, like I will say app1 uh, app1, for example, API. Anything you can say meaningful, another component of the same application. So this network I want to attach, and I want to publish the publicly reachable port from the cluster. For example, I want to publish 8080 from within the container. I know it will be 80, and if I am running, for example, HTTPD. So this time I'm using HTTPD as an image. This will expose the port 8080 to reach this cluster. This network will be associated, this name And we can also use replicas, I believe, is equal to 3. For example, I want to set by default its replica value is 1. I think I wrote the right command. Yes. So the -p for port, network, name, replicas. But initially we ran a very simple command. So this HTTPD image, it will pull down on from on the node where it's scheduled, and it will expose the port. Docker service ls. 3 out of 3 are up. Docker service ps app1 API, and you can see all these 3 nodes are participating to take the load of this new service. Now, if I go to my browser and if I try to open this any of the master or worker node with this port 8080, it will show us the default page that is used by this HTTPD. Okay, now I will type the IP of my worker node 1 with port 8080, and you can see it works as the default page for my HTTPD, and on any node I can do. So here we have to understand one more concept. For example, Docker uh, service scale replicas is equal to 2. I want to scale down the service. I don't need to write here replicas, just write the name of the service. So app1 API, I want to set to 2. So it will destroy one of the pod, one of the container, and Docker service PS. You can see only 2 are running on node 3 and node 2, but node 1 does not contain any container based on this service. Now when I will refresh this page, still node 1 is providing this service. So you can reach to this service from any of the node, from 12, from 13, this is worker node 3. So all the nodes are responsible to expose this port 8080. If I do a netstat ANTUP, you can see the port 8080 is exposed here under the Docker D. Netstat minus ANTUP port 8080 is exposed. So even though you have a lot of worker nodes and manager nodes, all will be responsible to provide you the reachability. Netstat 8080 port is open. Okay, now we have to understand the DNS functionality built in the Docker for the service reachable. So now if one of the pod is running on node 2, so I will go here on node 2, I will simple run docker ps, and this app API container is running here. This is the ID. I will do docker execute it, docker execute it, and then the ID and bash. I jump into the container, and we have docker service ls. I want to ping app1. I want to make a connectivity with app1. So what I will do, I don't believe I have ping command, so I must have to update, and then apt install ip utils ping -y. It will install the ping utility, and then I can ping app1 to see what IP has been created as a load balancer. So this 10.0.1.2 IP is working as a load balancer IP to reach the container running behind app1. So app1 has 4 containers. So let's quickly do a docker inspect to all the containers related to app1. For example, on node 1, this is the ID of the one of the container, and you can see 10. This is the virtual IP associated with this container that I inspected. Okay, and it's if I do this virtual IP is responsible to reach to this container. If I show you the IP 10.0.1.2, okay, and if I go to node 2, node 3, and docker ps and app1, these two containers are associated with app1, and docker inspect this container. So here you can see this is the actual IP of this container. So virtual IP is only associated with one container. Okay, so this is the actual IP created for this container, and the other one, it has a different IP. So by doing the inspection, we see that this is acting as a virtual IP for this service. If we can also do a Docker service ls, Docker service inspect, for example, app1 I want to inspect. So this service inspection will also give you the virtual IP. I believe I did some mistake, Docker ps, and this app1 on node 1, Docker inspect. Yes, I think I ran the wrong ID. So this IP you can see, this is the IP of the container. But when we inspect the service, it gave us the virtual IP associated with this service. So all the traffic, when we will do the by name connectivity from one container to another container, it will use this IP to reach, and it will do the load balancing, round robin load balancing among all the containers running uh, behind. So we understand this concept of service creation. We also did this network part, network creation. We did network ls. We did network inspect. We can also remove the network, and we create the service. We create the service with name, with network, with replicas, and we also update the service with the new network. Okay, we ls the service, we ps the service, we inspect the services. So if I inspect the service, docker inspect the service, docker service inspect app1, and I can use hyphen hyphen pretty. This will give us the details in short form, and in endpoint mode you can see the virtual IP. So we saw that how these services are working. Now, for example, we want to see a situation like we have 3 nodes, and if we do Docker service ps lab1, So you can see this service is span across all the nodes. For example, you can see on node 3 there is one container running, on node 2 one container running, and on node 1 two containers are running. So if we power down the node that is working as a leader as well as containing two containers for a service, and I believe for another service is also one container is running. So if we do the power down to this server, and the cluster will auto heal the failed containers. So node ls, the state is unreachable and unknown, and it will be in the state of downs, and the leader is now elected to node 2. Now if we look docker service ps app1, so here you can see on node 3 still it's showing in the running state, and docker service ls, it's showing 5 out of 4. Why? Because the new container created on a new host is also in the inventory, and the older one is also in the inventory. That's why it's showing 5. So when the node will be back, so you will see again 4 out of 4. But right now I want to show you 4 out of 4 containers are running. I do a ps, so you can see on node 3 both are in down state. On node 2, 47 seconds ago this container is running, and on node 1 two containers, and on node 2 two containers, so total 4 are running. Similarly, if we look the app1 API, you can see on node 3 it's shut down and it's relocated to 6 minutes ago on node 2. So this is the auto healing in case of cluster failure. Okay, so now if we discuss in the docker that if we create a different network and connect the different containers with different network, they cannot communicate with each other. Same here, we can do docker network ls docker network. For example, I'm going to create a new network like app1, sorry, I can say app2 net, and drivers overlay. So this this second network is created, and let me just quickly docker service create the name of the service. I will say app2, and its network I will use app2 net, and port exposure I don't want to do, and just the image formula HTTPD image I want to use. So I'm using these images because these are very light in weight. Okay, this service is running. So let's see if any container from this service tries to access app1 service, what happened? So docker service ps app2. So it is running on node 1. Okay, we are on node 1. Docker ps, and here you can see the app2 container just started 21 seconds ago, and this is the ID, and docker execute it bash apt update to install the ping utility. So let's ping app1. You see, this is unknown, but app2 is readable because it's connected with your app2. So all the services associated with app2 net can reach to each other. Okay. So this is a virtual IP, and again, if I just do docker network inspect, and you can say the app2 net, so you can see the virtual IP. Uh, just a minute, I think the virtual IP 10.0.22. Yeah, it's not mentioned here. Sorry, it should be the service, not the network. Docker service inspect uh, app2 net. Sorry, app2. So it's virtual IP is this. Okay, so we also understand this one. Now, if we want to do Docker service ls, and if we want to remove any service, so we can do Docker service rm, for example, app1. This service is removed along with its all containers. So this is done. Now, one more thing very important we have to understand that here there is a command docker service uh, update, and we can update the image of the service. So this is very useful while rolling updates. For example, your application is updated and your image is updated in the image repository, image registry, and you want to update your service with the new image. Definitely new image contains the new applications. So right now you can see the port 8080 is exposing my uh, HTTPD, and I showed you it gave me this it works page. For example, I want to update Docker service update and hyphen hyphen image, and developer update the image with the new application. Right now I don't have any update in the HTTPD, so I will just change the image to Nginx for service app1 API. So here it is removing the old container and creating the new containers with the new image. Now if we run docker service ls, you can see it's replaced with the new image. And if I just do a refresh here, sorry, the 13 is down. We power down the server, so that's why we can connect with 12 and 11, node 1 and 2. So this was cached page. Now I refresh, so now you can see the application is updated. So this command is very useful while rolling update and deploying new stuff uh, or testing new applications, yeah, under the service. So today we understand the basic concepts about the service, about cluster infrastructure, about the ports and service networks. So tomorrow we will, in the next session, we have to understand some more stuff related to this Docker Swarm, as well as the concept of Docker stack. So we will understand this Docker stack, how we can write our stack files, and how we can manage the multiple services with the single stack, what is the benefit, and also the concept of secrets and configs, and how we can use them inside the applications, and about something about the cluster events and stats, and how we can see the logs. So just final thing I will show you here, that logs, Docker service logs, and you can, for example, you want to see the log of this one. So it will show you the log of all the containers running under this service. This container is running on node 2. Its logs are there. This container is running on node 1. Its logs are there. So for example, I want to see the real-time logs. I will do -f, and now if I just do a refresh to this page, so definitely its request is going to one of the node. So its request goes to node 2, not on the node 1. So if I open a new session, then it will go to node 1. So this way we can see the real-time logs. So I hope you got the idea how this whole stuff is working. So in the next session, we are going to close this Docker Swarm, and we will go to advanced topics of monitoring and alert management and log management, everything.